Alright, let's look at real numbers. Okay, so real numbers fall into different sets of numbers. So for example, we have natural numbers, we have whole numbers, integers, and then rational. Now, it's possible for a number to fit into any of these categories and multiple at the same time. Okay, but then there's also another category called irrational. Okay, if a number is irrational, then it's not rational, and it's also not an integer, a whole number, or a natural number. Alright, let's go over what these mean. So, natural numbers, these are like counting numbers. So, starting with 1, 2, 3, 4, etc. Whole numbers are counting numbers, but we include 0, so with 0. So 0, 1, 2, 3, 4, and just continue to count. Integers are just like these, except we include negatives. So just like we have 0, 1, 2, 3, 4, and 5, and we keep on going, we go negative also. So negative 1, negative 2, negative 3, etc. Okay, rational numbers. So rational includes all of these and even more. So rational is any number that can be written as a fraction. And then irrational is simply not rational. So if it can't be written as a fraction, then it's irrational. So let's look at these two in more detail. So starting with rational. Rational is any number that can be written as a fraction, so anything such as like a over b. So this includes all integers. And of course integers includes whole numbers and natural numbers. So all of these are rational. So if you have the number 8, for example, the question is, how could this be written as a over b? It's just 8. Well, any integer can be written as that number over 1. So 8 is 8 over 1. Okay, but for example, 3/4, this cannot be written as a single integer, but this is rational. So all fractions are rational. And because all fractions are rational, decimals are rational also, because 3/4 is the same as 0.75. But it has to end. So 3/4 is 0.75. It doesn't keep on going on forever. So 3/4 is rational. If we look at some other decimals, 0.89 is rational. 0.5634 is rational. Okay, but there are other decimals that don't stop that are also rational, such as repeating decimals. Repeating decimals are rational. So for example, 0.3 repeated is the same as 1/3. So if it's a repeating decimal, it can be written as a fraction. You don't have to know which fraction it could be written as, but if you could see that it's repeating, then you know that it's rational. So even if it was like this, 0.583, 583, 583. This is the same as, and this keeps on going, 0.583 repeating, so this is rational. Or if it was something like 0.567 and the 7 keeps on repeating, that's also rational. It's just written as 0.56, and then the line just goes over the 7 because that's all that's repeated. So these are all rational numbers. So let's look at irrational. So if you have a number that comes out to 5.346271539 and keeps on going, and there's clearly no repeated term here, so it doesn't end with terms that keep on repeating, that's irrational. And you typically get something like this when you use a square root. So like the square root of 5, for example, would be an irrational number. So would the square root of 7, the square root of 8, those are all irrational. However, the square root of 9, for example, is rational, because the square root of 9 is simply 3. So after you do the square root, we just get this integer, so this is rational. But the square root of a number that is not a perfect square is going to be irrational. Okay, pi is irrational. Okay, why is pi irrational? Well, because this is actually a never-ending decimal. So a lot of people know pi as simply 3.14, but it doesn't actually stop there. Pi is really 3.14159265, and then a lot more decimals, infinite number of decimals. It doesn't stop and it doesn't repeat. So pi is irrational. But don't be tricked, because 3.14 is rational. This is a decimal that ends. So this isn't actually pi. This is what we use to estimate pi in most math problems. So 3.14 is rational because we're stopping at the 4, but actual pi is irrational.